Hi math friends, let's go ahead and check out our study guide here for dilations. So first I have suppose triangle MRB is similar to triangle YOU. Identify the corresponding angles. So if we need to, it might help to draw some triangles that look pretty similar. And remember we go in order. I go in the same order for the second one. So now I can see what matches up. M is congruent to Y. So angle M is congruent to angle Y. Angle R is congruent to angle O. And lastly, angle B is congruent to angle U. State the relationship. Well, the corresponding angles are congruent, which means they are the same measure. Corresponding angles are congruent. And because this is our notes here for us to check too, I'm going to say in parentheses the same, just so we remember that. Identify the corresponding sides. I'm going to look back to my drawing here. Now I get this MR is on the bottom here, and so is YO. I have to put these in order. They go in the same order, MR, YO, first two letters. So side length MR is similar to side length YO. Now I go on the side here. RB, side length RB, is similar to side length OU. Then we're going to do the last one. BM is similar to UY. State the relation between the lengths of the corresponding sides. Well, since they're similar, they're not congruent, they're proportional. So we can say the corresponding side lengths are proportional. I'm also going to say similar here. We should really say similar. We also need to know that that means they're proportional in this case. All right, last one here. Determine the lengths of MB and RB if MR is 9, YO is 3, YU is 4, OU is 5. I'm going to use that same drawing, but move it down here. And make sure to go in the same order. MRB. And on my other triangle, I have to be in the same order. I have to go YOU. I cannot go in the reverse order. All right, so I have MR is 9. YO is 3. YU is 4. OU is 5. So now I got to find these. Check out this relation. 3 times 3 is 9. I'm going to do the same here. Times 3, 12. I can do this because they're similar, which means they're proportional. So now I got my final answer. Side length MB is 12 centimeters. And side length RB is 15 centimeters. Here's my final answer. Got my work shown. I'm good. All right, your next page, we have to do a dilation and then answer some questions about it. So they give us the coordinates here, and we're going to scale it with a scale factor of 0.5, so times a half. So half of 1 is half. So D prime, 0.5, 0.5. Let's plot that right away. Half, half. Here's D prime. We're scaling it. We're also using the center of the origin as the center of dilation, so all I need to do is multiply. I don't need to do anything else for these. E prime, multiply that by half. Half of 5 is 2.5. Half of 2 is 1. 2.5, 1. I got to be precise there. I got to be really clever, and I can do that. F prime, multiply those by a half. Half of 2 is 1. Half of 5 is 2.5. So I go 1, 2.5. F prime. And it should look similar. So everything shrunk going towards the origin there. What are the coordinates of the dilated image? We just did that, but let's go ahead and write our coordinates here nicely. I don't know why we're asked for it after we do the dilation, but we're just going to do it in order. All right. How did you determine the coordinates of the dilated image? We can say we multiplied the original coordinates by the scale factor. That's really all we did. It's the dilation and enlargement or reduction. Well, by looking at it, it's a reduction. It got smaller. Also, our scale factor is less than 1. So we're going to say reduction. Explain the reasoning. We can use either reason. So I'm going to say the scale factor is less than 1. What is the relationship between the triangles? I was supposed to do GHI here, not prime. So D should be G, and then H, and then I. So that's what we should have here. G, H, I. So we went in order. All right, so we got that corrected. What is the relationship between the two triangles? They are similar. We're not asked for any explanation there. All right, this one's similar here again. We're going to do EFG into PQR. So EFG, and we're going to use a scale factor of 1.5. All right, so remember 1.5 is a little tricky, but we're going to think about it. What are the coordinates of the dilated image? We're going to do this one first here. So I'm going to just copy the original E -4, 8, F -4, 3, and G -2, 3. We're going to multiply everything by 1.5. So here's how I got to think about this. I'm going to remove the negative for now, and this is going to go to point P. 1 times 4 is 4. Half of 4 is 2. 4 and 2 together is 6. And then I need to remember to make it negative again. Let's do the same for 8. 8 times 1 is 8. Half of 8 is 4. 8 and 4, 12. Let's check out point Q then. Half of 4. Oh, we did that already. 4 times 1.5 is negative, so -6. Now 3. 3 times 1 is 3. Half of 3 is 1.5. 3 and 1.5 is 4.5. Let's check out R. I got -2, so 2 times 1 is 2. Half of 2 is 1. Together they're 3. It was negative, so it's got to be -3. And now I've got 3 times 1.5. Same thing, 4.5. Right? So that happens sometimes. We got the same thing there. Let's go ahead and plot those. -6. I'm going to go all the way up to 12. Looks like I go all the way up here. So here's P. And then Q, -6, 4.5. 1, 2, 3, 4.5. And then R, -3. And then 4.5. Be clever there. Here's R. And we're going to plot this. So here we got an enlargement. And we knew that because our scale factor is more than 1. All right, so how did you determine this again? You can say we multiplied the coordinates by 1.5. And we just saw it. It's an enlargement this time. Explain the logic. Well, the logic is we multiplied by a number greater than 1. And just like the previous problem, these triangles are similar. They are similar. This redundancy just kind of helps us to remember that, and that's why I really think this is here. All right, now this number 4 is a tricky one. This is probably the trickiest one on here. So we have to dilate this, but we're going to use this point as the center of dilation. Now this is tricky stuff here. So for this one, we got to use I'm going to start with the originals. So I'm going to use some space here. C is negative 32.8. R is 0.12. And then Y is negative 12, negative 4. All right. So to do this, I have to move this point to the origin. So I have to do the opposite of this. I'm going to do a plus 2 for X. I'm going to do a minus 1 for Y. So after we move this to the origin, then we can multiply. So if I move this plus 2, because it's the opposite of minus 2, I'm going to have negative 30 and 7. Then I'm going to have for R 2, 11. For Y, I'm going to have negative 10, negative 5. All right, now I can multiply by a fourth. Now, multiplying by a fourth can be kind of tricky. None of these multiply by a fourth nicely to get a whole number. So I can think of it as this. I can think of it as divide 2, then divide 2 again. That'll get me there. So half of 30 and then half of that. So I can think of it that way. So my C prime is going to be negative 7.5. Half of 30 is 15. Half of 15 is 7.5. Half of 7 is 3.5. Half of 3.5 is 1.75. This isn't C prime yet. Sorry about that. Now this one, I'm going to get 0.5, 2.75. Talk through this one again. Half of 10 is 5. Half of 5 is 2.5. Half of 5 is 2.5. Half of 2.5 is 1.25. All right. Now because we move this over here, I have to do the opposite to move it back. So now I have to do a minus 2 to X plus 1 to Y. Minus 2 plus 1. All right, so when I do that, now I have my final coordinates. C prime, negative 9.5, comma, 2.75. I'm running out of room here. That's interesting. I don't have a lot of room on this page. So I'm going to go ahead and write my finals up here. C prime, negative 9.5, comma, 2.75. Then over here, R prime is negative 1.5, comma, 3.75. And then my Y prime, I'm going to put over here, Y prime, negative 4.5, comma, 0.25. So this is definitely a tricky one. I would advise you to do this one last. All right, let's go to number 5. State which of the pictures are similar to the given picture. So here's our given picture. Which ones are similar? This one looks like it got like stretched this way and then stretched this way. So that's not similar. It's got to get stretched the same, kind of like you're zooming in or zooming out on things. So it looks like this one is and this one is. So this one is clearly an enlargement. And this one is a reduction. I would say this one did not get stretched properly, and you can kind of see that there. All right, let's go ahead with number 6. Consider the trapezoids. We have to complete the sentence to explain how this works. So this is a dilation, and let's check out this. I got B and B prime. So it tells us here A, B, C, D into A prime, B prime, C prime, D prime. Right? So if it's going this way, it's got to be an enlargement. That's really it. Number 7, trapezoid A prime, B prime, C prime is a dilation of. So this is tricky. This goes this way. Dilation of means we start with this. So we go this way, C to C prime. This is another enlargement. We know just by looking at that. All right, this last section here, Now this one, don't be too confused by this one. We need to describe a sequence of transformations, so more than one. So I'm going to look at this ABC going here. Now it looks like it flipped and it got bigger. So to me, this looks like it's a reflection and then a dilation. Okay. Now this is where it's kind of confusing though, because I could also say, or you could do the dilation first and then you could flip it. Okay. There's another choice though. You could also think of rotating it, because these aren't really necessarily perfect here. And then I could rotate. So I could rotate and then do a dilation. Or I could do my dilation and then rotate. The only thing I really can't do here is a translation. That really doesn't make sense with this. All right, let's check out this last one. This last one, we're thinking of 3 transformations here. So as long as you can reason through this, we're going to go here, ABC to here, or ABCD to EFGH. So this looks like it got spun, and then dilated, and then maybe translated. Seems about right. I'm also looking here. This is a short side. This is the short side here. So actually, it gets spun, dilated, and flipped. So we did a rotation, we did a dilation, and then we did a reflection. I would argue that you could do those in any order. Again, for this one, just don't choose translation because we gotta spin it and flip it here. So I could do CBA, CAB, BAC, any order of rotate, dilate, reflection is going to be okay. And I'm going to write that in these notes here because I know sometimes we just kind of miss it. So we're going to say any combination of rotate, dilate, and reflection. Okay, but it's got to be a combination. We got to have all 3 for this one. All right, so hopefully that helps you, and always give yourself a chance. All right, you're going to be okay. Take care, math friends.